Hi, I am Dr. K. Prakash, Assistant Professor in Theory Department. Today I will present a lecture on data preprocessing techniques. The main aim of introducing this particular topic is to familiarize the students with the concept of data preprocessing and various data preprocessing techniques. The main objectives of this particular topic is to demonstrate the importance of data preprocessing and their techniques with regard to machine learning concepts. At the end of this lecture, the students will be able to learn the importance of the data preprocessing and various types of data preprocessing techniques such as data cleaning, data integration, data transformation and data reduction. The outline of this lecture is why preprocessed data, why data are dirty, why data preprocessing is important in the machine learning context, and what are the major tasks in the data preprocessing: data cleaning, data integration, data transformation and data reduction, and finally the summary of this lecture. Why preprocessed data? In real world, the data are dirty. The dirty in the sense impurity data. The data may be incomplete, the data may be consisting noisy data, the data may be inconsistent. So incomplete data in the sense the data values may not be recorded, may not be stored. So this is the reason for incompletion of data. And sometimes some irregular values or garbage values may exist in the data. That's why that is called as noisy data. Sometimes there may be in mismatch and inconsistency in the data. That is called as inconsistency in the data. Why data are dirty? Why? Because here the data, so many systems are connected together, and all these systems to gather the data from various locations and various systems, various locations. These data may be incomplete, and the main sources of the data incompletion is the data may not be recorded, the human or hardware software problems and other issues related to the network. And noisy data, the main reason for the noisy data is faulty data collection instruments, errors in the data transmission. Inconsistent data may come from different data sources and the violation in the functional dependency. Also, there is an existence of duplicate records, which is called as redundancy. Why data preprocessing is important in machine learning context? Whenever we are dealing with data, the data should be high quality. When there is no quality data, automatically it will reflect on the result of the data. So we will get no quality in the results. So coming to the machine learning context, here whenever we are inputting the data should be high quality data, or otherwise it will impact on the model's performance. So it is very important to perform the data preprocessing techniques on the collected data. And these are the major tasks in the data preprocessing. First one, data cleaning, data integration, data transformation and data reduction. So here data cleaning, we will discuss one by one. Data cleaning. So data cleaning in the sense removing of anomalies, any noisy data, removing other issues in the data. So data integration, the data may be collected from different data sources. So all those data may be represented in different formats. So if you want to perform any algorithm, or if you want to perform any machine learning technique on the data should be integrated and should be represented in a unified format. Coming to the data transformation. So normalization of data is very essential. Why? Because here the columns may consist of different data. So one attribute data may dominate other attributes data. To avoid such problems, we need to aggregate or normalize the data. Coming to the data reduction. During the machine learning implementation, here all the attributes may not be useful. So some irrelevant attributes are need to be reduced. That can be done in data reduction. This is an illustration of major task in the data processing. Data cleaning. Initially the data having some impurities, then after applying data cleaning the data is pure. And coming to the data integration, here this is the different types of data sources. All the data sources are being transformed, being integrated into a single type of data. And data reduction, here if we can observe different transactions and attributes. All these attributes are not essential. Some of the attributes may be removed from the data set, and those attributes can be used in the machine learning process. And data transformation, representing the data in a specialized form. The values may be in between 0 and 1. Coming to the data cleaning tasks. Here filling in missing values, identify outliers and smooth out noisy data, correct the inconsistent data, resolve redundancy caused by the data integration. We will see one by one. Missing data. Missing data means the non-availability of the data. Here many tuples may have different values, but sometimes if you observe this table here, coming to the income, there is some missing of information. So this is the example for missing data. How can we handle the missing data? So we can ignore the tuple, we can fill the missing values manually, we can fill automatically by using a global constant or mean value, but among these the imputation of most probable value is the best method to handle the missing data. So how do you handle the noisy data? So there are different techniques. Binning. Under that, smoothing by bin mean method, smoothing by bin median, smoothing by bin boundary. And also there are other techniques, regression and clustering. We will see the binning techniques. Here this is a sorted data price. Here the values are in a particular order, ascending order. So it is very essential step when the data are in zigzag manner, it is essential to sort the data in a particular order. Then only we can perform the binning operation. So here there are two types of binning methods here, equi depth and equi width. Here we can consider equal frequency of the bins are considered, each and every bin consisting 3 values. Bin 1 3 values, bin 2 3 values, bin 3 3 values. Here coming to the smoothing by bin means. So we will find out, first consider bin 1, we will find out the mean value of these 3 values. So the mean value identified is 9 and all the values in the bin 1 will be replaced by 9. Similarly, bin 2 is replaced by the mean value 22, bin 3 is replaced by the value 29. And coming to smoothing by bin boundaries, here as the name indicates, we will consider minimum and maximum values. So in this particular bin 1, the minimum value is 4, maximum value is 15. So whenever we consider a particular value, for example 8, here 8 is very nearer to the minimum value, that's why here it is replaced by 4. Similarly in bin 2 it is 20, here there is no operation performed. Here bin 3 25, 28 and 34, here 28 is very nearer to 25, that's why it is replaced by 25. So coming to the data integration. Data integration means combining data from multiple sources and need to represent the data in a single format. So here integration of data from different sources, entity identification problem, detecting and resolving data value conflicts. Here there may be some conflicts while representing the subjects of the data. All those should be resolved by integrating the data. And coming to the data transformation, smoothing, aggregation, generalization, normalization and feature selection. These are the various techniques under data transformation. Smoothing involves in the removal of noisy data, aggregation involves in the summarization of data, generation involves in concept hierarchy climbing, and there are 3 types of normalization techniques. Here min-max normalization, Z-score normalization and normalization by decimal scaling. By implementing these normalization techniques, here the value will be represented in a specified range such as 0 to 1 or -1 to 1. And coming to the attribute selection or feature selection, here some of the attributes will be selected for the machine learning process and some of the attributes will be removed from the process. So that is done by feature selection. We will see one by one in detail. Coming to the smoothing. Smoothing in the sense removal of noisy data from data set. Here we can implement different algorithms to remove the noisy, where earlier we discussed that binning operation, smoothing by bin mean, smoothing by bin median, like that here we can apply. And coming to the aggregation. Aggregation is the term representing summary. Here the data is stored and presented in the form of a summary. Here if we see the example, here in a particular year 2015, there are data related to quarterly Q1, Q2, Q3, Q4. Similarly 2016 and 2017 data also represented quarterly. So what is the aggregated form of this data? The aggregated form is all the quarterly information is aggregated, summarized, that is represented on the right side of the model, right side of the figure. Okay. And discretization. Discretization means representing the data in terms of intervals. Say for example, if you consider a time values 3 p.m. to 5 p.m., 6 p.m. to 5 p.m., 6 p.m. to 8 p.m. Concept hierarchy generation. Concept hierarchy in the sense representing lower level data into higher level data. If you consider one example, for example address, street is the lower level, city is the next higher level, state is the next higher level, country is the top level. So here sometimes we need to represent the data in a higher level, in a top level. That's why we need concept hierarchy generation. And normalization, data can be represented in a small range such as -1 to 1.0. Coming to the data transformation, normalization. Here min-max normalization, Z-score normalization, based on the given data, minimum and maximum values are identified, and the respective data will be represented, substituted in an equation, and we will get the data in the normalized format 0. Here we got 0.716. And coming to the Z-score normalization, here the main values are mean and standard deviation. Based on these values, the values will be substituted and we will get the normalized value. In general, the Z-score normalization will have the values in the range of -3 to +3. And coming to the normalization by decimal scaling, here we will have the data, and the data will be normalized based on the following steps. So first we need to find out the maximum absolute value in the given data. So from the above example we got 701, and next we need to divide the data by the number of digits in the identified value. Here we have identified 3 digits, so we need to divide the given data by 1000. So this is the most important point. We need to find out how many number of decimal points are to be scaled. And after applying that, we got normalized data, that is -0.01, -0.301, and so on. So next, coming to data reduction. Data reduction, dimensionality reduction, numerosity reduction, data compression comes under the data reduction strategies. Here the main functionality of the data reduction is to reduce irrelevant features from the data. And also here it will avoid the curse of dimensionality. It allows easier visualization. Techniques for dimensionality reduction are principal component analysis, feature selection, and wavelet transforms. Coming to the numerosity reduction, in this method the data representation will be represented in smaller forms. So it means we are reducing the volume. So techniques for numerosity reduction are parametric and non-parametric methods. Under parametric method, regression, log linear method. Under non-parametric methods, histogram clustering and sampling. Coming to the data compression, here the compressed form of the data can be represented. The compression can be lossless or lossy. When there is no loss of information during the compression, it is called as lossless. When there is a lossy compression reduces information, it removes only the unnecessary information. Here lossy in the sense, even though it reduces the information, the original data will not be removed, only the unnecessary information will be avoided from the learning process. And data reduction, here the feature selection is the main problem, and the solution for this problem is stepwise forward selection, stepwise backward elimination, combining forward selection and backward elimination, and decision tree induction. Here it is represented with some example. The initial attribute set is A1, A2, A3, A4, A5 and A6. In the forward selection, all the best attributes will be selected. So after reducing the data set, the best attributes identified from this method are A1, A4 and A6. And backward elimination is, here in this particular operation we will eliminate the worst attributes from the data set. After performing this step, the identified attributes are A1, A4 and A6. And coming to the decision tree induction, here the same attribute set is identified, is considered, and the main concept in the decision tree is identification of root node. So here the root node and the intermediate nodes are the test nodes, and at the bottom we will have leaf nodes. So these are the actual classes, actual output in the decision tree induction. From the reduced data set, we have identified 3 attributes, A1, A4 and A6. And the most important technique in data reduction is, that is related to dimensional reduction, principal component analysis. So principal component analysis is a dimensional reduction method. it is most often used method in dimensional reduction. So these are the steps involved in principal component analysis. Standardize the range of continuous initial variables, compute the covariance matrix, compute the eigenvectors, create a feature vector, recast the data along the axis. Here the axes are orthogonal to each other. And coming to the representation of principal components, here there is a plot represented which is called as a scree plot. On x-axis we will have number of principal components, on y-axis we have eigenvalues. Here there is an elbow like structure. Here this is the point that represents before this particular point. Before this particular point we will have the most important principal components. Why? Because the first component will have more variability, second component less variability when compared with the PC1, and third one, and so on, like that. Here whenever we move the number of components, the importance of the variable will be reduced. So here this is the most important plot that is useful for finding the number of PCs. Coming to the applications of PCA, here the dimensional reduction and feature extraction can be done by PCA, and very effective in data preprocessing, noise reduction, and easy to visualize the data. And coming to the limitations, here PCA assumes linearity and normality in the data. Sometimes data may not be linear. So the non-linearity feature, non-linearity characteristic in the data may not be suitable for PCA, and also the outliers can easily affect the PCA. And coming to the summary, here the data preprocessing techniques are very responsible to convert raw data into the desired format which is understandable by the machine learning algorithms. And also several data preprocessing techniques are data cleaning, data transformation, data integration, and data reduction plays a key role in the data preprocessing. These are the books suitable for referring data preprocessing techniques. These are the web links, and these are the self-assessment questions. To remove noise and inconsistent data, which technique is needed? Data cleaning is a suitable answer. And normalization by dash normalizes by moving the decimal point of values attributes. Here as we are moving the decimal point, so here the solution for this question is decimal scaling. And these are the terminal questions related to the data preprocessing techniques. And thank you.